Dr. Abhay Dharamsi, Dean, Faculty of Pharmacy, Dr. G.S. Chakravarti, Principal, Parul Institute of Pharmacy and Research, Dr. Lalit Lataja, Principal, School of Pharmacy, Dr. Bhavin Vyas, Professor, Maliba Pharmacy College, Uka Tersadia University, faculty members, and my dear students. On behalf of Faculty of Pharmacy, Parul University, I welcome you all in today's webinar on selection of specific tests for the hypothesis testing. For today's webinar, we have an eminent guest with us, that Dr. Bhavin Vyas from the Maliba Pharmacy College. I heartily welcome sir for this webinar. It's honor to introduce Dr. Bhavin Vyas. She is currently working as an associate professor at Maliba Pharmacy College in Department of Pharmacology and Pharmacy Practice. He has a completed D.Pharm from Dr. Dairam Patel Pharmacy College, South Gujarat University, B.Pharm from Mahatma Gandhi Vidya Mandir Pharmacy College, M.Pharm from NDMVP College of Pharmacy Nasik, Pune University, PhD from V. Namas South Gujarat University. She has completed dual certification in medical writing and clinical data management from Physics Learning Academy Private Limited and post-graduation in Diploma in Clinical Research, Institute of Good Manufacturing Practice, India. His area of interest is clinical trials, pharmaceutics, regulatory affairs, life sciences, and standard operating procedures. So, welcome, sir. If any participant have any questions during the webinar, please type them into the chat box, and we will discuss it later during the question and answer. Now, I request Dr. Bhavin Vyas to begin the session. Over to you, sir.
Good afternoon, all. My voice is audible.
Yes, sir.
Slide is also
yes,
visible. First of all, I'll be very much thankful to Manisha madam as well as Lalita madam and Abhay sir for giving me opportunity to share my views on a small expertise what I have with me with the student. So with that brief, I'll be directly starting with the topic that is given to me, that is selection of specific test for hypothesis testing. I have been told that there will be a presence of 8 semester students. So my talk will be according to that, the language what I'll be using or example what I'll be using, so that they can easily understand. According to that, I'll be explaining the details. So as per the new PCI syllabus, every student who are there in 8th semester, they need to undergo something called as project. Now when they undergo project, so they do some experiment. They do experiment, and after doing experiment, they need to compile that the results of that experiment, and they need to present that, and based on that you need to conclude something. So for conclusion, we require something called as statistics. So this statistics is nothing but a study of collection, analysis, interpretation, presentation, and organization of data which is collected by you by doing some experiment or by doing some survey. By that, you are collecting, analyzing, interpreting, presenting, and organizing data. That is something called as statistic. And this statistics is considered as a backbone of any research in any field, not in pharmacy. If you take, I can say, commerce, if you take medical field, if you take dental field, in everywhere where they are doing research, they need to know about something called as statistics. So this is considered as a backbone. So with use of statistic, what we are doing is we are converting the amount of information or data which we have collected by doing experiment. We'll be converting that data into something called as information. So that's why you need to know about this, what is statistics and different hypothesis testing or tests which are available, which test you should select, when to select, and how to select. So my topic will be on that, The brief one, initially I'll be giving you idea about what is type of data, what type of different hypothesis testing test is available. Uh, then I'll be going into how to select what parameter you need to identify, and depending on that which test you can go for. And I'll be giving a glimpse that by hand you can do, or is there any availability of software by that you can do. So according to that, my webinar will be there. So starting with first, uh, that is type of data analysis. So if I talk about pharmacy, in case of 8th semester, you might have taken project in pharmaceutics, you might have taken project in pharmaceutical chemistry, pharmacology, or I can say in pharmacognosy. Or if you have pharmacy practice, you might have also uh, might be doing in pharmacy practice. So each and every department might use a different type of data, and by that they might be doing a different type of data analysis. So generally, whatever data you will be collecting, generally I can classify that into four type of data analysis. First type is known as descriptive analysis. Descriptive analysis, where what are the characteristic of respondent, that is you will be presenting in the form of mean, median, standard deviation, percentile, extra. So if you are doing a project in clinical research, so uh, you will be collecting data of that age of that patient or age of that group of individual. So you will be presenting the mean age, what is there in your research. So then how many are graduate, how many are undergraduate, how many are, I can say, from uh, high profile family. So this type of thing you can say, this type of analysis is known as descriptive analysis. You will be just representing your data in the form of mean, median, percentile, in that form. That is known as descriptive analysis. The second most important that we do in pharmacy, that is known as inferential data analysis, where we, after collecting data, will be inferring something, will be drawing conclusion. In case of descriptive analysis, we are not drawing a conclusion. We are just describing what we have collected in presentable form, either in a form of tabulation or in a form of graph. That is descriptive. While in case of inferential, after collecting data, I'll be making some conclusion. From based on my data, I'll be concluding something. That is nothing but inferential statistic or data analysis. That is what are the characteristic of population. For example, make comparison between two or more groups. So in inferential statistic, I'll be doing like that. For hypertension, I'll be giving drug A and drug B. So I'll be in inferential data analysis, I'll be concluding that drug A is more potent than drug B, or drug B is more efficacious than drug B. If I'm doing that type of analysis, that is nothing but known as inferential data analysis. The third type is known as associative type of data analysis, that are two or more variable related in systemic way or not. That is nothing but correlated, correlation, regression. That is correlation between two or more variables are there or not. So you might have learned subject called as pharmaceutical analysis, where you might have learned that if you increase the concentration, the absorption will be also increased of particular compound. So that is, you have one something called as dependent variable, independent variable, and you are finding that because of change in A variable, there will be change in B variable, either positive variation or negative variation. So you want that, that is there any relationship between that two kind of data what we have collected, and if we are doing that, that is known as associative data analysis. The fourth one, that is known as predictive data analysis. Predictive data analysis, where generally, which is not that much used for I can say for UG, but in PG, many students will be utilizing this called as predictive data analysis, where can we predict one variable if we know one or more other variable. That is, for example, typically used to forecast the future probability. So in predictive data analysis, what you will be doing is the data what you have collected by doing some experiment, you will be forecasting that if in future this type of uh, experiment, if you do this type of result will be there. So you will be predicting that, you will be generating something called as mathematical model, and if you change one variable, what will be the outcome, that is can be predicted. If you are doing that type of data analysis, that is known as predictive analysis, predictive data analysis. So generally whatever type of experiment you will be carrying, at the end you will be doing either of this four type of data analysis, which is called as descriptive data analysis, inferential data analysis, associative data analysis, or predictive data analysis. Going to next, that is, when you do statistic, you should know this two terminology called as parameter and statistics. Parameter and statistics. So we do always carry out experiment to generalize something, or to note it down or lay down it to population. So if I want to know that how many, what is the average height of particular class, so it is not necessary that in class, if there is 100 student, I need to measure each and every student height and then make it average. So that is considered as a population. So for that population, rather than measuring each and every individual student height, what I'll be doing randomly, I'll be selecting few student, 10, 15 or 20 student, and I'll be measuring. So that is known as sample statistic. And from sample, I'll be the result of sample, I'll be laid down that to the population of that context. So that is nothing but there will be two things. We always do have the samples. We have samples. So we do data analysis on sample, and then we conclude for population. We conclude for population. So this two terminology you should know, that if you have in statistic a mean which is noted in form of mu, that is you should consider that as a population mean. And if it is written as a x bar, so you should consider that as a sample mean. You should consider as a sample mean. So main part in bar statistics, or main part in selection of hypothesis test, is data type. When you are doing experiment, you will be collecting data in form. If you are doing some experiment related to tablet, you are having, so what is the weight variation, what is the time required for drying, how much amount of binder I require. If we are doing experiment in case of pharmacology, and then after administration of particular drug, how your rat or mice is behaving, or what is the change in blood pressure. So that type, so you will be collecting data, collecting data. So that data, what you are collecting, I can differentiate in various way, and depending on that, I need to select particular data analysis test, so that it can we can inference, or we can draw some conclusion, or we can have some uh, conclusion from that. So I can divide data into mainly two type, called as discrete type of data, discrete type of data, discrete type of data or continuous type of data. When I say discrete type of data, this can be only have a specific value. It will be having specific value. While continuous ratio, that data is take any numerical values or that might have a decimals too. That have decimals too. So I have given an example of continuous type of data is known as like height, weight, blood glucose, blood I can say blood pressure. So that there might be blood glucose 120.22 milligram per deciliter. It might be there in decimals too. So that is known as continuous or ratio data. When I say discrete data, further I can divide that into two types. A discrete, either it will be presented as a whole number. So there will be no decimal. Like the data can be any whole number, number of student, number of book. There is no possibility that half student is present or half book is present. You need to present in a form of whole number. 5 books are present, 6 books are ratio data. Interval and ratio is also known as continuous data. Continuous data. So if you want to present that, data, so you can present in a manner that I have presented in this slide. So if we have collected nominal data, that is we have collected how many males are there, females are there, or how many I can say caste-wise distribution if we have done, how many Buddha are there, how many Parsis are there, how many Hindus are there. That is known as nominal type of data. So if you want to present, you can present in the form of mode, which is known as measure of central tendency. Okay. If we have collected data regarding where I can have an order, so I can present that data in a form of median or in a form of mode. Mode is nothing but most frequent value which is coming in your data. Median is nothing but a middle value which is there in your data. If you arrange that from low to high, and then the middle one which is coming, that is known as median. Mode is most frequent one. If you have 10 data where the 5 number is more frequently coming, then I can say mode is 5. Okay, so that is nothing but central. But Interval and ratio, in that you can mainly present in the form of mean, as well as in the case of ratio also mean, that is average, the number of observation divided by sorry, you need to sum it up all the individual uh, value divided by number of observation, that will be getting you the average, or I can say mean. So that can be presented. So when you collect data, it will be in this form, and you will be presenting in this manner, in this manner. The next part, coming to the next part of my talk, that is hypothesis. So when you do experiment, you should um, rational approach to research, that say you should form something called as a statement, that is nothing but known as hypothesis. So hypothesis is nothing but a statement or assumption about the relationship between variable. I have given few statements. So before starting off your experiment, you should have some assumption, or you should note down some statement. So then, by collecting data, we will be establishing relationship, that the assumption what I have stated, or the statement what I have given before starting of my experiment, it is accepted or it is rejected. So that's why rational approach to research, that say you need to form hypothesis, a statement or assumption about relationship between variables. So few example I have given in this slide, that is student who eat breakfast will perform better on the maths examination than student who do not eat breakfast. This is my a statement or assumption. Then I'll be doing my experiment. I'll be collecting a data exam performance from the student who have had a breakfast and student who had no breakfast, and then I'll be comparing marks, the average mark or mean mark. So if I find difference, then I can say the assumption or statement what I have given was correct, or I can say accepted, or it is rejected. The second example I have given, that student who experienced taste of anxiety prior to English exam will get higher score than student who do not experience the taste of anxiety. Like that, the rational research say that you need to state a statement, that is nothing but known as hypothesis. So this hypothesis, what we need to, why we need to state that is nothing but also for the assumption what we are making before starting our experiment is correct or not. For that, we are forming a statement. So that's why this is also, apart from hypothesis testing, this is also famously known as significance testing. Significance testing, the statistical analysis of hypothesis resulting into classify as a inferential data analysis. So generally, in case of hypothesis testing, you need to state two statement, or you need to give two statement. First statement is known as null hypothesis, and second is known as alternative hypothesis. Null hypothesis is noted as H naught, H naught, and alternative hypothesis is known as H1 or HA. Okay, that is H1 or HA. Null hypothesis or alternative hypothesis. So, what are the criteria for hypothesis construction? So, you should empirically, uh, it should be empirically testable whether it is right or wrong. It should be specific and precise. The statement in hypothesis should not be contradictory. It should be specifying the variable between each which the relationship is established. You should describe the issue which is there. So by that you can give, I can say, statement, and that then you will be doing experiment, collecting data, and finally concluding that your statement what you have given prior to doing experimentation is accepted or rejected. Accepted or rejected. So as I have told you, there are two type of hypotheses are there called as null hypothesis and alternative hypothesis. So that state, null hypothesis states the assumption to be tested begin with assumption that the null hypothesis is true. So if I am doing experiment on hypertension, I have two drug, that is drug A and drug B, drug A and drug B, and I'm assuming that both of will be. I'm testing which is better, which is not better. So for this type of experiment, my null hypothesis will be drug A and drug B is equally effective in treatment of hypertension. So here I'll be stating in null hypothesis there is no difference between the two variables what I have. That is considered as a null hypothesis. So in bar statistics, you always try that you will be giving the statement of in form of null hypothesis, where you will be noting that there is equality between two or three or four variables, and by doing experimental you are trying that that is wrong, or that should be rejected. Then you find a difference. That is known as null hypothesis. Alternative hypothesis is always opposite to null hypothesis. So in previous example, what I have given, that drug A and B is equally effective in treatment of hypertension. Here in alternative hypothesis for that will be, there are three, I can say two alternative hypothesis statement I can give. Drug A is better than drug B in treatment of hypertension, or drug B is better than drug A uh, in treatment of hypertension. That might be the alternative, or not equal. If I want to give only one, drug A and drug B is not equally effective in treatment of hypertension, I can say in that terms also. So that is about your alternative and null hypothesis. So when you carry out experiment, uh, there are chances of error. There are chances of error. So that is given by, I can explain using this slide, where you have given statement, you have formed alternative hypothesis as well as null hypothesis. Then you have done some experiment. So from experiment, you have something called as statistical decision, and in reality, you might have some uh, reality statement. So according to that statistical uh, decision, that you will be rejecting your null hypothesis. But in reality, the null hypothesis is correct. For example, null hypothesis here is that drug doesn't work. But by doing experiment and by doing statistical test, you conclude that the drug is effective or drug is working. So in reality, what is there? The drug is not working. But by doing experiment and by doing statistical analysis, you are saying the drug is working. So this is error. So this type of error, very much blunder, I can say, that is known as type 1 error, which are also famously known as false positive, false positivism, which are noted as a alpha or significant level. We will be maintaining or will be controlling this error by prior establishment of significant levels. So second condition might be that by statistical decision you will be saying that you conclude that drug work, and in reality also it is working. So that is nothing but known as the correct decision. The second situation, that by statistical decision you are saying that you fail to reject null hypothesis. In a way, you are accepting null hypothesis, but in statistic it is always uh, they say that you never say that I'm accepting null hypothesis. Your statement should be like, you have failed to reject null hypothesis. You fail to reject null hypothesis. That you conclude that there is insufficient evidence that drug is working. Okay, so the first condition, you are saying that it is not working. In reality, it is also not working. So that is a correct reason. The problem will be here. A drug is not working, and you conclude that drug is working. You are concluding that drug is working. That is known as type 2 error. Type 2 error, which is known as false negative. Which is known as false negative. And we can control that by uh, prior administration or prior fixing of uh, power. Prior fixing of power. Okay. How uh, how much power of statistical case is required. That we can, so we can manage alpha type 1 error and type 2 error by priorly deciding something significance level of power. So this is what I have given between relationship between errors. So I'll be skipping this slide because it is not important for you. Now, as I have told you that I'm having this type 1 error and type 2 error. So type 1 error, I can nullify or I can manage by by before starting or before doing any statistical analysis, if I fix my significance level, if I uh, decide my significance level, that beyond this, I'll be considering that this is not effective, or this is effective, or this is significant, or this is not significant. So generally, in medical field, uh, p-value is considered is if it is less than 0.05. So if your p-value is less than 0.05, then you say there is a significant amount of evidence you have that indicate that you have there is a difference between the variable what you have, that is nothing but known as significance or p-value. So generally these are the steps that you need to take when you are doing hypothesis testing. That is, first make assumption, or you need to specify your alternative hypothesis and null hypothesis. Then you need to select significance level, that is alpha. Always you will be selecting at 0.05. 0.05. Then the important thing, what the second part of my webinar, the selection of appropriate test will be there. And then after that, after selection, you will be deciding the what is the rule for decision. What is the rule for decision? And according to that, you will be either rejecting your null hypothesis or fail to reject null hypothesis. And based on that, you will be interpreting your findings. So these are a few steps that you need to take when you are doing something called as hypothesis testing. Hypothesis testing. So now I'm coming to this part called as the step 3. Select an appropriate test statistic. So which test you should select, that I'll be coming. So before starting that, I need to clarify this two terminology called as dependent variable and independent variable, because what type of statistical test you can select for your hypothesis depends on how many dependent variable are there, how many independent variable you have, and at what level you have, only one level or two level or three level. Based on that, the hypothesis test which is there will be different. So that's why I need to clarify these two terminology called as dependent variable and independent variable. Dependent variable means it is a variable, the experimental changes or control and is assumed to have direct effect on dependent variable. If I plot a graph, so my x is always will be something called as independent variable where the experimental I'll be changing. So if I am plotting a graph of different dose watching versus change of blood glucose level, so on x-axis I'll be having first point as 1 milligram of dose, second point will be 5 milligram, third point. So the experimenter will be changing that, and that change will be directly having effect on your dependent variable. So independent variable is what is changed by experimenter or controlled by experimenter. So that is nothing but uh, independent variable. X is often variable used to represent independent variable when you have that different statistical formula where x is considered as an independent variable. It is a variable that represent quantity that is being manipulated by experimenter. Okay. While dependent variable is a variable being tested and measured in an experiment. So what we are measuring? So first example, what I have given that I'm changing the dose of drug and I'm measuring the blood glucose level. So blood glucose level will be my dependent variable. Will be and as name say dependent variable. So it will be depend on your independent variable. It is nothing but it represent quantity whose value depends on the how independent variable is manipulated, how it is changed. Based on that, you have dependent variable. And generally, in equation, y is here representing your dependent variable. Dependent variable. So coming to selection of test for hypothesis testing, a researcher has to simply answer the following question. If you are able to answer following question, which will be leading to correct selection of taste. Correct selection of taste. So these are the question, 6 question you need to ask to yourself, and the answer of that will lead to selection of your taste, selection of hypothesis taste. So how many independent variable you have, that is how many independent variable with dependent variable. If you have one independent variable with one dependent variable, then there is a test. At what level of measurement independent variable is? So independent variable, how many levels means it is only 1 point or one dose or at 3 different doses. So one dose it is one level, 3 dose means it is a 3 level. So what level of measurement in the independent? Here independent variable. Okay. What level of measurement dependent variable? So you are measuring dependent variable. You are measuring in form of nominal data, in form of ordinal data, in form of interval data, in form of ratio data. So in what form we are measuring? Because if it is changed, the statistical test will be changed. That's why. Are the observation will are dependent or independent? Depending on that, do comparison is involved in population to population, sample to population, or two or more sample are compared, and is hypothesis is being tested are comparative or you have relationship. So if you are able to answer this question, that will be indicating particular case. So in my next phase, I'll try to answer this, and by answering this, the, I, you will be leading to selection of particular test. So the second way of selecting, answering this second way, you should know what type of data you have, how they are distributed, they are normally distributed or not normally distributed, and what is the number of group. This is the another way of selecting a hypothesis test. Hypothesis test. What type of data? Either it is nominal data, ordinal data, or continuous data. That is distribution. That is, you will be plotting something called as histogram, and from histogram I will be knowing that it is normally distributed or not normally distributed. So if it is normally distributed, there are particular statistical tests which are known as parametric test that you need to select. If it is not normally distributed, then there is a set of tests which are known as non-parametric test that you need to select. So from distribution of data, it leads to 2 points. Either I need to select parametric test or non-parametric test from distribution of data. And number of group, what I have. So I have your independent variable at 1 level, 2 level, 3 level, 4 level. So that will be giving you a number of group. So this say the about your independent variable. Independent variable. So this is how you can check your normality. That is by plotting. This is something called as normally distributed. In center, mean will be there, and on left and right side, it will be equally distributed. A Bell-shaped curve, if you observe with your data frequency, then you can say it is normally distributed. So you need to select parametric test. If it is not there, you need to select non-parametric test. So these are ways by you can check the normality is there or not, but it is not beyond this scope of this webinar. So I'm skipping that slide and I'm directly going on the selection of case. So uh, I'll be explaining in two ways. First, I'll explain by this way, and then I'll be explaining by way of how many dependent, how many independent variables are there. So this will be saying that what type of data you have collected. Suppose, assuming that you have collected continuous data, body weight, blood glucose level, average weight of your tablet, average concentration of your binder that you have added. So that type of continuous data you have collected. So first and foremost thing, that if you have collected that continuous data, first you need to check that it is normally distributed or not. If it is not normally distributed, then there is a scope. You can convert that or you can transform that data. So that you should transform that data. Transformation, either you can take log of that, ln of that, you can take percentage of that. You can transform that data, and then again you will be checking normality on that transformed data. And if it is normally distributed, then you can select something called as parametric test. So first, what type of data? So I have type of data, continuous type of data. Then if after transforming, if it is not following normally distributed, then you can go for something called as parametric test. Non-parametric test. If it is normally distributed, then you can go for parametric test. Now, after distribution of normally distributed data, you came to conclusion that I need to apply parametric test. Now, the second point that you need to consider for selection of type of hypothesis test is how many independent dependent variables are. So if you are comparing a fixed value, suppose I want to know what is the blood glucose level in Farm D 5th year student. So standard blood glucose level I can consider as I'll be comparing that average value of that students with a standard value called as 120 milligram per deciliter. So I'm comparing, if I'm comparing with a fixed value, if I'm comparing my data, what I have collected with a fixed value, then you should select a test called as one sample t test, one sample t test. But rather than that, so here what I have independent variable at 0, or I have only dependent variable. I have dependent variable on it. Now, forgot about that. If you are comparing that with a fixed value, you should select one sample. Now, if you are comparing between two groups which are independent. So I have a group of, I can say in a group of 10, I'll divide into 5 into group A and 5 into group B. Now, if I have differentiated these two group and then I have administered a drug and I'm measuring the blood glucose level, so how much it is reducing in group A and group B. If I want to compare in that, then I need to select something called as independent sample t test, where I have a two different group. But there is also chance that rather than independent group, you might be having dependent group. So before giving or before administering drug, we are measuring what was the blood glucose or what was the blood pressure, and after administering a drug, what is the blood glucose level or what is the blood pressure. If you are doing in that manner, so that is called as comparison within the group, then you should carry or you should select a test which is called as pair t test. Okay. So there are chances that you don't have one group or two group, you have more than two group. Now, if you have more than more than two group, then the test which is going you can select is known as one-way ANOVA. One-way ANOVA. So if you have three different independent group A, group B, group C, like that, then it is known as one-way ANOVA. But like previous one, that is this one, where within the group, you might also have within a group. So I have given a drug. I have given a drug. Before administering drug, I have measured a parameter. Before administering drug. After administering, after 3 months, I'll be measuring the parameter. Then in same person, I'll be measuring after 6 months. So here what I have, three levels. I have three levels. So I cannot select the previous test, that is parity test. So for that, I should select something called as one-way repeated measure ANOVA. One-way repeated ANOVA is analysis of variance. Analysis of variance. My talk is limited to selection, assuming that you know some tests which are available. So that's why I'm not going to explain what is TTS, what is that is a different talk where I require another 1 hour or 1.5 hours. So I'm just telling you, if you have this type of data, if you have this type of characteristic, you should select this type of test. Then how to carry out that is a different way, a different talk. Okay. So in nutshell, if you have, because in pharmacy generally, if you are carrying out experiment in I can say Supix or QA or in cognosciology, generally you will be final outcome, you will be having a data which is continuous type of data. So that's why you should follow this uh, I can say flow. By that you can select your particular test. But if you want to go beyond this, or if you want to select, so there is another point of view, another point of view. By that also, you can select this test for hypothesis. Test for hypothesis. By knowing how many number of dependent variable and independent variable you have and what type of data you have collected, based on that also you can select. So few of slides I'll be having which will be explaining that, so this slide explains that if you have one dependent variable and you don't have independent variable. So in previous slide, the condition is this type. My arrow is moving on that is on previous slide. That is, I have one dependent. So I want to know what is the change in blood glucose level when I administer a drug. With the population. So standard value I have 120 milligram per deciliter. So I don't have independent variable. I only have dependent variable blood glucose level. Okay. So if you have 0 independent variable and 1 dependent variable, if you have measured in the form of continuous data, that is this interval, and it is normally distributed, then you should select a test called as one sample t-test. But rather than interval or continuous data, if you have measure in the form of ordinal or internal data, you can select a test called as one sample median test. If we have categorical data, male, female, like that, categorical data, then you can go for binomial test. Or if you have categorical data, either you can go for binomial or chi-square test for goodness of fit. So this is a condition, first condition, where you have one dependent variable and zero independent variable. The second condition, one dependent variable and you have one independent variable with two levels. Means group is independent variable and you have two group 1 and group 2. So that is at two level. Okay. So that is nothing but one dependent variable and there is one independent variable. Now you observe what type of data you have collected. If it is continuous, interval, ratio, and it is normally distributed, then you should select two independent sample t-test or independent sample t-test. Previous one, this independent. Previous slide, this independent sample t-test. If you have collected data which is not continuous one, it is ordinal and interval, then there is a non-parametric which is equivalent to this parametric test, is known as Wilcoxon or Mann-Whitney test. If you have categorical data, then you can select Fisher extract test or chi-square test. Now the second condition, that is you have third condition, where you have one dependent variable and independent variable you have, that is with more than two level. So you have three groups. So if it is measured in continuous and normally distributed one-way ANOVA, the equivalent to one-way ANOVA ordinal non-parametric test called as Pushkar-Wallis test. If it is categorical data, you can go for chi-square test. Now the next condition, with one dependent variable and one independent variable with two level which are dependent. So in previous slide, this type, dependent type. So that is nothing but one independent variable with two level which are dependent and match group. So if you have measure or continuous scale and normal distributed, you should select a test called as pair t-test. If it is ordinal and interval, Wilcoxon sign rank test. And if it is categorical, McNamara test, you can select. You can select this test. Next condition that you have one dependent variable, one independent variable which are at more than two levels. Here, dependent at two levels. Here, more than two levels. If you have measure at continuous level, interval level, and it is normally distributed, then the test name what you should select is one-way repeated measure ANOVA. One-way repeated measure ANOVA is parametric test. For equivalent non-parametric test is known as fragment test, where you will be having your data type of data which is ordinal type. Categorical data, that is repeated measure. Logistic regression you should select. You should select logistic regression. If you have more than two independent variable which is independent, then there are n number of factorial ANOVAs are there. Factorial ANCOVA, MANOVA, you have that type of ANOVA will be there. That is known as factorial ANOVA. If you have measure on continuous scale. Ordinal scale, logistic regression. Categorical, factorial logistic regression is required. Next condition, here where you need to correlate each other test. So you have one dependent variable, one independent variable, which is interval type, and you want to know the relationship between that. And the type of data, what nature of dependent variable or type of dependent variable is continuous data or interval data with normally distributed. Then you need to have a correlation test, or you can go for simple regression test. Non-parametric test, that is non-parametric correlation and simple logistic regression, you can go if your type of data is ordinal or categorical. One dependent and more than one independent variable, then multiple regression you can go, or there is called as analysis of covariance, which is famously known as MANCOVA. Okay. Or categorical multiple logistic regression or discriminant analysis you can go for. So this where the condition where you have one dependent variable. If you have more than one or two plus dependent variable and one independent variable, then one-way MANOVA, multivariate analysis of variance, you will be having. These are advanced statistics. Generally, during I can say post-graduation or graduation project, we rarely utilize this part where we have more than two dependent variable. But nowadays, where in pharmaceutics they are doing something called as design of expert. They are using experimental design. So the software name is Design Expert software, which is handling this type of condition. Simultaneously, the more than two dependent variable you have, and you also have more than two independent variable, and what is the effect of that independent variable and two more than one or two dependent variable simultaneously you need to verify. Then you can go for this type of analysis, which is known as one-way MANOVA, multivariate analysis of variance. That type of thing you can go for. But we have software which are available with that, and generally in UG don't prefer that. Preferred one is what I have explained previously. Okay. So that is nothing but the selection of paste, and then after that you also need to go for post hoc analysis. So during my presentation, I have given something about that there are two kind of test, parametric and non-parametric test. So this is nothing but the information that I want to give, that is the difference between parametric and non-parametric test. That is, when I say I do parametric test, my population is information about population is completely known. In case of where I don't know anything, then I can select. Oh, forgot about this. The general route, what I'm going to tell, when to select parametric and when to select non-parametric. It should be based on the first thing. Your data is normally distributed or not normally distributed. If it is normally distributed, you go for parametric test. If it is not normally distributed, non-parametric test. Other way, which is general rule. General rule. If you have measured your dependent variable, the type of data what you are selecting, if it is continuous and ratio, interval and ratio, generally it is normally distributed. So if we have measured in continuous form or interval or in ratio form, you go for parametric test. If you have ordinal data or categorical data, you go for non-parametric, because generally they don't follow normality. So this is a general rule where what type of parametric test or non-parametric test I should go for. So this is general rule. Okay. So these are a few formulas that I have given, that if you have one sample t-test, mu, as I told you, mu means population mean. With that I will be comparing population mean. Here the difference, m is difference between prior and post. Here it is independent. So sample 1 difference divided by minus sample 2 difference. That based on that they have given formula. So utilizing this formula you can select, and after that you need to go for observing tables. This is about t-test, so you should go for t-distribution table. So you need to go for this t-distribution table, and the degree of freedom, according to that you need to identify the difference is that or not. This is not, I can say it is beyond the topic what I have given. So that's why I'm not explaining, just I am giving a glimpse that after selection you need to carry out this type of thing. And this is about one-way ANOVA. It's also I'm skipping. So, and this is final, I can say, slide where I can say this is the table. By that you can select. So what level of measurement you have, categorical, nominal, and how many sample you have. According to that you can select the test. According to that. So if you remember this table, then you can select the test. The previously what I have explained, that is summarized in this table. Okay. Thank you. If you have any doubt, you can ask me. I hope, Manisha madam, I have justified the topic what I have given.
Yes, sir. Very nicely covered. Any participant who want to ask the questions?
I know I am very good orator and very good explainer. So what I am explaining, everybody will be digesting that. So I assume that nobody has any doubt what I explained. I can understand that they might not have any question. Thank you. Again, once again, I thank Manisha madam as well as principal of the School of Pharmacy and Dean of Pharmacy in Parul University, Dr. Abhay sir, for giving me opportunity to share my knowledge with your students. Thank you very much.
Sir, one question is there. How measure of association between two parameters are measured in statistics? From Fido's Banu Doctor.
It is in chat box.
Yes, sir, it is in chat box.
Okay,
How?
I'll check it. How measure of association between two parameter are measured? If you want to have association, if you have measure in form of continuous data, then regression is the best way. You go for linear regression, and if it is in categorical data, then chi-square test. Chi-square. So you can check by that. So if I give example of that, so if you are measuring that, I'm changing the concentration, and what is the change? What is the change in absorbance? If we are measuring in such type, then it will be nothing but regression, because my dependent measure I have measured in continuous form, in the form of absorbance. It is continuous form. So it will be relation will be regression. I need to apply regression. The second condition, I am giving a drug or I am giving a vaccine. It is effective or not? Yes or no? My answer will be yes or no. So in that, I need to check something called as I need to apply called as chi-square test. Chi-square for independence. So it will be giving association. Hope
Okay, sir.
I am justifying.
Okay, sir. Fido's. Sir, thank you.
Yes, ma'am. Thank you, sir.
Okay.
Sir, please stop presenting your screen. Sir.
Okay.
Thank you very much, sir. Dr. Bhavin, sir. Thank you very much for accepting invitation. Namaste, sir.
Namaste. It is my pleasure, ma'am, that I need to able to talk with you in such a webinar.
Yes, sir. Thank you. And please visit Parul University also in near future for some purpose.
Sure.
Yes, sir.
I many student of my from Maliba Pharmacy College now as a teacher. Even Manisha is also from Maliba also,
Yes, sir.
and the Kusnud as well as
Yes.
Sachin,
Yes.
even Asa. So I know many students. Even Abhay sir was also with us for few years. So
Yes,
it
sir.
will be very much. I will be very much delighted to visit your institute.
Yes,
I'll
sir.
be sure visiting your institute.
And sir, now in 8th semester B.Pharm we have biostatistics subject. So the topic which you have taught is very useful for our students.
Yeah. So
Thank you so much, and please come whenever we have this type of sessions or workshops. We'll definitely
sure.
invite you, sir. Thank you.
Thank you very much.
Thanking you, sir, for accepting our invitation as a resource person within a short time, and it's a very useful topic for the final year BPharm students, and they get the knowledge about the selection of tests for the hypothesis testing. So, as a token of appreciation, I would like to felicitate with the e-certificate on behalf of Par University. Accept it, sir, from us.
Thank you. I accept your e-certificate. Thank
We
you.
will send thanking you later and invitation later after the
Sure.
completing of the session.
Sure. COVID has teach us many things for accepting e-certificate and everything. What we are not knowing now, we are accepting everything.
Okay, sir. Um,
Once again,
Look-
thank you.
Okay, sir. I would like to express my gratitude to all the participants of the webinar for the presence and contribution to make this webinar as a great success. Okay, all the participants will get the e-certificate after the filling the feedback form link, which was said earlier. Okay. Thank you, sir. Thank you, all the participants.
Now I have permission to leave the meeting.
Yes, sir. Yes, sir. You can leave.
Okay.
Okay. Thank you, sir.
Thank you.